Thanks. So my name is Dan Miller. This talk is titled Thinking Beyond a Rotation-Only Controller. What I'm going to be going over today is basically some interesting ways to use the GearVR controller. So I'm going to talk about what the GearVR controller can do, how it works, how you can integrate it into Unity, and then just some general workflow tips and utilities for developing for GearVR inside Unity. So my name is Dan Miller. There's my email address as well as my Twitter. And so just to start off, I want to tell you a little bit about me. I come from a gameplay programming background. So I started out developing mobile games, moved to the Bay Area, did some interactive brand experience, and then before joining Unity, I was working at a smaller company when they first started developing and prototyping on high-end VR systems. So I released a couple games for the HTC Vive. And now at Unity Technologies, I travel around. Technically, my title is XR Evangelist, and I go around giving some presentations and talks, as well as building a lot of sample applications for new technologies focused on augmented and virtual reality. So the overview for the talk today is basically going to be talking about what the GearVR controller is, how it works, the different sort of buttons and functionalities of it. The technical integration into Unity, how you can integrate it into either an existing application to take advantage of it or a brand new app. And then some of the features that we've released recently that allow for some support of that. Next, I'm going to talk about getting input from the controller. So the controller has a couple different types of buttons and how you can query and use those, specifically inside of the Unity engine. And then lastly, this is kind of the meat of the talk, is something I'm calling the key turn controller interaction. And I'll talk a little bit about how that works, what I'm doing, and then show some sample code and applications on how you could start to use that and think about that. Then last but not least, I'm just going to go over some general workflow tips for developing in mobile VR, specifically focused here on the GearVR. And one thing I wanted to note is I am going to show some code examples as well as some sample videos and applications. And all of these are freely available on my GitHub, which I'll have at the end of the presentation there if you guys want to go and grab those yourself. All right, so the GearVR controller. I basically have it here up in my hand right now. You can see there that it has a variety of different buttons, things like the touchpad, which is both a sensor that determines where your finger is and a physical button itself to press down. It has a back key, a home key, and some volume buttons. And last but not least, it has a trigger that kind of naturally rests under your index finger. Now, a couple things to note just when developing for this in general is that the home key and the volume keys are actually restricted at an operating system level. Your application can't take advantage of these buttons specifically. These are reserved for, obviously, turning the volume up and down. And then the home key recenters or reorients the controller, as well as goes back to the Oculus Home. And you'll notice that the back key, while it's not restricted as a click button, it is restricted as a held button. So if you hold the button down for 5 seconds, it's going to go back in your application, and you can't necessarily take advantage of that, but you can take advantage of it as a single click button there. All right, so for the Unity integration, if you wanted to start developing an application right now, you would basically configure your Unity project to be in the Android build settings. And then under something we call XR settings, there is a virtual reality supported checkbox. And because the Samsung GearVR is in a partnership with Oculus, Oculus developed the SDK there, and so you include that inside the virtual reality SDKs. Now, one thing to note if you're developing on an older version of Unity, that these XR settings were traditionally called VR settings, and those are going to be actually under the Other Settings tab previously. So in 2017.1, we're moving all of these XR settings, which is things like virtual reality and augmented reality, into its own little settings panel there. And once you actually select this, then if you build out an APK and push it to your device, then right away the camera that's in your scene is now going to be controlled through the cell phone's kind of IMUs, so the accelerometer and the gyroscope for moving and positioning around. And there are a couple more things that you're going to need to do in order to start accessing this controller inside Unity. So in 2017, we shipped something called the Tracked Pose Driver, and what we're trying to do is basically abstract and integrate native integration for VR controllers, headsets, and other things like that directly into Unity. And so this is a built-in component that you can configure to get positional data from any sort of tracked device. So you can see here, I've set the device type to be a generic XR controller, the pose source to be left controller. So this on the controller option, this has left and right controller. And that's actually something you configure inside your Oculus application when you pair your controller first, if it's either left hand or right. And then lastly, the tracking type is rotation only. So that option has rotation only, position only, or rotation and position. And because the way that this controller works is that it doesn't actually know where it is in space, and it only has the kind of accelerometer and gyroscope to know how it's oriented rotationally. And so I've configured it to be rotation only. And then there is an update type there at the bottom. Most of the time you want to leave this as is. It's just telling it when the controller position or rotational data gets updated in the application there. So this allows you to basically have the controller configured for rotation. Well, in order to get input, currently in Unity, you will need to add an additional SDK, which is developed by Oculus called the Oculus Utilities for Unity. And so what this does is this actually wraps some of the input and gets back data from the controller so that you can start querying those inside your application. And I'll go over a little bit of what's inside that here in a moment. And then the other thing just to mention, when you're developing anything for the GearVR, if you want to have an application run on your device, it needs to be signed by Oculus, and you do this through creating an Oculus signature file, which is through the developer portal from Oculus. That's kind of on a per device basis. All right, so the Oculus Utilities. This is basically a kind of sample application that has a lot of helpful features built by Oculus specifically for the Unity engine. So the first one is just kind of a nice convenient 3D model of the GearVR controller. So this is, has the optimal geometry as well as a nice texture for it. And so if you do want to represent your controller inside the app as the exact controller itself, it's really convenient to be able to use that. There's a couple other things like the OVR lint tool. So that's the Oculus VR lint tool. And what that is a special tool that they built that actually kind of scrapes your entire project and will be able to expose or highlight some potential issues in performance on your application. So if you've ever developed for mobile VR, you know that performance is a big issue or something you need to kind of focus on early and often. And what this tool will do is help expose some of those potential issues that you might have. There's other things like a prefab for the controller that's configured to be kind of left or right hand and then turn the model itself off and on, rather if the controller is detected. Some example scenes like you can see here. This is just an example controller scene that gives you back a bunch of data like the acceleration of the controller as well as when buttons are pressed. And then a little bit of editor camera emulation that allows you to move the camera around in the scene similar to how you would on device. All right, so basically the way you query input from the controller is through this Oculus Utilities. And what this does is give you an OVR input class. And it kind of wraps Unity's built-in input system. But instead of using Unity's kind of input.get button down or things like that, you're instead going to use OVR input. And so there's the options for get down, and get up. And so get is just querying a bool if it's true or false. Get down and get up are going to give you the exact frame at which those buttons were pressed. And then lastly, I want to mention that there is a touchpad here, and they have built some swiping gestures into that. So it has up, down, left, and right. A lot of the times you're kind of pointing the controller maybe at a UI thing or something like that, and you kind of want to scroll through it. The one thing to note here is that these swipe gestures don't actually get called until you've lifted your finger up. So that's just kind of how they're sampling that there. And lastly, this is something that I just ran into when I was starting to develop and build this presentation here, is you have to be a little bit careful about adding custom axes and what sort of buttons are associated with those. So I had something that looked similar to this. It was a input axis called test and had the positive button of escape. And that button there was actually kind of consuming the back button. So when I was building my sample app to test all the buttons and clicking them, I wasn't getting anything back from the OVR input button back. So you want to make sure to be a little bit careful if you're adding additional input axes inside of Unity. All right, so now I'm just going to kind of briefly mention here's how the input axes actually look in code through Unity. You'll notice the back button is just an OVR input.button.back. One thing to note here on the touchpad is that there's actually 3 different things listed. So I mentioned earlier that this touchpad is a physical button itself, so you can click that down, and that's going to be actually the first call there. So you're using OVR input button primary touchpad. The next one is touch, so you can tell when the user is actually touching this button or when it's not, and so you could start applying some logic to that. And then lastly, the axis 2D is going to give you a 2D vector for the X and Y to figure out the exact position at which the user is touching the touchpad there. And of course, there is the primary index trigger here for the trigger. And then the swipe buttons are actually listed as buttons, but again, the left, right, up, down for querying that. All right, so I've kind of mentioned it before, but basically this controller is something called a 3DOF, or 3 degrees of freedom. And what that means is that it knows about its pitch, yaw, and roll, so it can rotate and position itself how it's actually positioned in the real world, but it can't tell that I'm holding the controller here or I'm holding the controller here. And so that's because it doesn't have any sort of sensors or information or data about where it is positionally in the world. It only really knows about its own orientation rotationally, so 3 degrees of freedom. So what I'm going to talk about now is something that I'm kind of calling the 4th degree of freedom. And what you're doing is you are consuming one of the rotation axes, but it allows you to add a little bit of depth to your project and to your controller. And you'll see in some of the upcoming videos here that once you kind of get it right and once you get comfortable with it, it does almost feel like you are kind of reaching out or you are using a positional rotation or axes here inside your app. All right, so this is something that I'm calling the key turn. I want to make a small note here that this was actually, I was kind of first inspired to do this by a developer friend of mine named Nathan Rowe. He's building a VR application called Sculptor VR, and he's currently targeting all the mobile VR platforms by the end of the year. So I'll go ahead and play this video. And what you'll see here is that as I rotate the controller here, that this red ball attached to it actually extends out, and then as I rotate the controller back to more of its natural kind of resting position, then the ball comes back. And in this scene setup, I've simply kind of attached box colliders to the boxes, and there's a little sphere collider on this red ball here, but you can see it's a little easier to see at the beginning here, that as I rotate the controller to the left here and then pull it back, that's how the ball is kind of controlled there. And you might have noticed at the end, what I'm doing is I'm actually kind of going out and grabbing and then kind of scraping one of the boxes towards me. And so this is this key turn method that I'm talking about, where I'm just rotating the controller a little bit like that, and then extending something out onto it, and then I'm able to really pull things towards me or manipulate objects that are further away. You know, a lot of the times when I've seen people use the controller, they're just actually kind of using the rotation data, doing something with maybe like a laser pointer or something like this. But this allows you to more naturally feel like you're kind of reaching and interacting with the world. All right, and just to show kind of the code and how I'm actually doing that, basically what I'm doing is this is the update function. If you're familiar with Unity, this is basically the function that's called every frame here. And I'm just storing the Euler angles inside that current rotation, and then I'm checking the rotation of the controller itself. So the controller like this, which is its natural resting position, is at 0 rotation in the Z. And then I'm checking if it's between 0 and something I'm calling max rot, or max rotation. And what I've found is that 115 degrees is a pretty natural rotation and kind of the max limit that you want. So most of the time you kind of move the controller like this, which would be about 90 degrees. And sometimes you do exceed that a little bit. But once you're approaching 115, your hand or your arm starts to get a little bit uncomfortable. And so I've just kind of limited to that. And when it's between that, those values there, then the ball or that object is going to extend out. And then when it's not, it's going to start returning to its original position there. So you can kind of do this and then return it back here to where it first started. All right, so this is another example where I'm using actually the same sort of kind of functionality here with the key turn. But I've added a little additional functionality of when you hit the touchpad, the hand actually grabs. You'll notice there's a little bit of animation there. And what I can do here is I can actually go out and specifically grab objects. And you'll see I start to kind of stack these objects together. And this gives me a lot more control than what normal just kind of rotation, things like that. Now, I am a little unsuccessful in doing this third stack of the box here, but you can see I do attempt a couple times, and maybe something that could make specifically stacking boxes or kind of doing things like that a little easier is if I potentially kind of smoothed out or restricted the rotation of the hand itself, but still kind of extended it out into that there. And so you can see I'm just doing that, and just kind of, again, just naturally kind of rotating it out, grabbing it, and then I can, again, position it over to where I want, and then just let go using the touchpad there. All right, so now I just want to kind of go through again the code for this. It's fairly simple here is what I'm doing in this first block here is I'm testing if there's an active controller. And if there is, then I'm going to be querying the actual input for it on the touchpad, the get down and the get up, to do a simple grab and release function. And you might notice at the bottom is that I'm actually using Unity's default input system for querying the spacebar as well. And I'll go into the editor and kind of talk about how that works here in a moment. But this is something that I did to more quickly iterate and test this functionality that I was working on. And just to show you guys the grab and release here, basically I'm doing something called an overlap sphere, which inside Unity is kind of like creating a little sphere at a position that I determine, and then any sort of colliders that are interacted with that. That's I switch the rigid body, which is a physics component, to be kinematic. I set the parent to be on the actual hand itself. And then I add it to a list of colliders there, and then when I release it, I just loop back through that list, set them back to be is kinematic false, and unparent them so that they fall there in the world. And so now I'm going to go ahead and hop into the Unity editor here, and you can see that this is the similar scene to what I showed in the video. And one thing to note here is that as you saw in my script, is that I did program some functionality for the spacebar. And now, if I go ahead and start the simulation and hit play here, there is some code that actually turns the render models or the 3D representation of things off. So I'm going to go ahead and just turn those back on to visualize them. But all I'm doing is actually just querying the input of this controller right here. And so as I rotate it inside the editor, you can see that I'm actually getting the same functionality as I do on device. And this allowed me to much quicker kind of iterate and develop this and make sure that my code and logic was sound. And so you can see I can actually kind of move this up a little bit here and then start the rotation like that. And then now if I go down here, I can hit the space bar and I can actually do kind of the same functionality that I'm doing. Now it's just kind of manually testing there, but this allows me to more quickly iterate on some ideas as well as just some code and things like that. And so this is all through the editor, but the functionality transfers directly over to the controller here. So I'm just querying the rotation on that object specifically. All right, so now I'm just going to briefly talk about some workflow tips, and these are just kind of general tips for any sort of mobile VR development and something that I found really useful. So the first one is enable developer mode. So inside the Oculus settings on your application, there is a way to basically enable developer mode. And what this allows you to do is run GearVR applications outside the headset. So if you've ever done any mobile VR development in general, most of the workflow is you build the APK, you somehow put it on your device, you put it in the headset, you calibrate the controller, you start doing tests, and then you need to remove the device from the headset and kind of do the things in reverse. And what this developer mode allows you to do is actually just run the full application. It has the split rendering there, but it doesn't have to be required to be in the device. And you can access this through the GearVR services, managed storage, VR service version. You click that 7 times, and that enables the developer option, and then you can go ahead and enable that mode there. The next thing is build and run. So Unity has, when you're just building up your APK, it has the option to build it to somewhere on your device specifically or on your computer, or you can actually do build and run. And what that build and run option is going to do is it's going to create your APK, push it on a device that's plugged in, and then instantly install it and launch it. And so that just speeds up the workflow of creating applications in Unity and then pushing them and testing them in device. And then lastly, this is just something that I found really useful, is I highly recommend getting something like this. So this is just like a mobile stand that I have, and it allows me to just kind of set the device on here. I can do this orientation as well. And with these 3 tips, I was basically able to kind of set up a workstation here where I was developing in Unity, I was pushing my applications directly to my device here, and then I can still utilize the controller and still test out a lot of these functionality, but I don't need to put it fully in the headset. And that just really speeds up and streamlines any sort of development that you're doing. Now, if you're familiar with VR development, you know that you're always going to want to make sure you are testing it on device, especially to validate some of the performance issues or just the visual look and feel of the game. But for quickly iterating or just testing simple features, these tips really streamline development and really allow you to much quicker iterate and fix issues and things like that. The last thing I want to mention is obviously just debug early and often. Mobile VR can be really difficult to hit those performance benchmarks. And one thing that the Unity editor now offers is something in the console window called Connected Player. And what that does is it allows you to link up through the Android debug bridge to get callbacks from the device itself. So if you're not familiar with ADB or Android Debug Bridge, it's basically an application that allows you to query things that are happening on your device through a command line. And you can actually link that through the Unity editor so that when an application is running on your device, it's plugged into your computer and Unity is running, you can click that there and all the logs will get filtered into the Unity console, and that allows you to clear things out or collapse certain calls that are all the same. And that really helps just get back any sort of debug messages or anything like that that you've put in your code. And then also there is a specific flag you can do just for straight ADB. Now it's going to look a little less pretty than in the Unity editor, but I definitely recommend checking that out in the Android tools. All right, so general tips. This is something that I found here is basically, let's see if I can get these videos to play. All right, it can't be loaded. Basically what's happening is that by default, inside Unity, your main camera inside any empty scene is actually configured with the near clip plane to be at 0.3. And what happens really often is that this is too far away for virtual reality. And in virtual reality, you kind of necessarily don't want things too close to your face, but when you're looking around, you need to make sure that you are seeing certain objects. And if it is at 0.3, then you'll get a lot of clipping where you either won't see your device at all because it's in front of that near clip plane, so it's completely occluded or not rendered at all, or it'll just kind of be in that weird in-between zone where you are getting some clipping. So if you change the near clip plane to 0.1, that's actually what I do for all of my virtual reality projects. That gives you kind of that more natural or closer clip plane that you would expect in a headset. So I highly recommend doing that. And if you are using the GearVR rig that comes with the Oculus utilities, then you're going to want to make sure you change the center eye anchor. That's the actual object that becomes the main camera when you're building and running applications. All right, so I just want to mention Unity is doing a small lottery here. So if you want to have the opportunity to win a pro license, and inside that pro license, you get kind of a Essentials pack, which is a collection of Asset Store assets. You can come by our booth here on the second floor and enter to win one of those, and then prizes are sent out next week. And all right, that's pretty much the end of my talk. So I mentioned that all the utilities and all the scripts that I showed today are available for free on my GitHub there, which is that link right there. And if you guys have any questions or anything in general with developing for VR or developing in Unity, you can feel free to reach out to me via email from there or hit me up on Twitter from that. So thanks. I think we have some time for Q&A if anyone has any questions, and I'll also be around after the talk and at the booth as well.
So just a quick question. The headset and the controller, I guess, could also be looked at as being both pointing devices. Are those abstracted away as like separate devices, or would it somehow be seen as like two instances as the same type of device?
Are you talking about the like tracked pose driver there, or just kind of in general with building your applications?
Just kind of in general.
Yeah, so I know some platforms require that if you are using the controller that you can't use your head as input. So like then that's kind of at a platform level when submitting to certain stores. But if you do want to abstract that and kind of, let's say you're building an application maybe for GearVR and Daydream and Cardboard that doesn't have a controller, you could definitely set up some sort of system where you just attach like a script that's basically looking at the forward direction of whatever it's on. So, you know, controllers are going to have that rotation axis, and then your head is going to have the same. So potentially you could just set some script that you would attach on whatever moving object you have accessible. Any other questions?
Is there a way to interface more than one controller currently on the Unity side of things?
So that kind of tracked pose driver that we have is basically extendable to any sort of, you know, basically any sort of number of tracked devices. Now that's going to be a support question more on the operating side level. As far as I know, the GearVR only supports one connected controller, but I think it does support multiple connected Bluetooth devices. So potentially you could get around it through that. And then right now, the tracked pose driver is basically kind of like just a list of enums that we've seen, but you can use VR nodes, which is through the Unity API, to abstract that out more if you potentially add more controllers.
Thanks.
Just a quick question, because I haven't really tested on the newest GearVR. Is the touchpad on the controller behave the same as the touchpad that used to be on the GearVR? In the previous version?
Yeah, so it's basically the exact same in that the one difference is that the controller actually has a physical button of the touchpad, and the touchpad on the headset is just kind of a static touchpad there. And so you kind of have additional access to this. Now the one thing to note inside Unity is that this touchpad here on the headset acts the same as the touchpad or the same as a mouse pointer, but the one on the controller does not. So if you're doing certain logic for, let's say you're kind of testing on inside Unity and using the mouse pointer position or things like that, that would directly map to the touchpad on the headset. But this one needs to be queried through those OVR utilities.
Oh, okay. So, because I've built a script or a plugin where I can make the touchpad behave like a actual gamepad. So I was wondering if I can just apply the same thing.
Yeah, so I mean, you'd basically kind of apply that same logic of how you're controlling things via touchpad, and yeah, it should work very similarly here on the controller itself.
Okay, good to know. Thank you.
All right, thanks a lot.